Okay, so today's lesson is inverse variation. We talked about direct variation. So this is another type. And we remember that direct variation had to be in what form? What did the equation look like? Y equals, now that's our slope-intercept form. For direct variation, it's what? Y equals kx. And we said sometimes we see it as y divided by x equals k. And that's direct variation. But today we're going to look at inverse variation. This is just something to remember. And each of you has 24 little squares, right? And what I want you to do is come up with see how many rectangles you can make with your 24 squares. And you have done this activity for a variety of reasons. You did it when you looked at like the factors of 24, right? When you were whenever you learned factors. I don't know, maybe 4th grade. You've done this activity. We're going to use the same activity, but we're going to talk about it in different ways. So what I want you to do is I want you to make a chart with the length and the width of each of your triangles. And once you've done that, then we're going to look at what you got. Okay, you all were making rectangles, not triangles. And so let's talk about the different rectangles that you made. Shannon, list 3 of the rectangles that you made.
6 by 4, 3 by 8, and 2 by 12.
Okay. And Molly, give me 3 that you guys came up with.
1 by 24, 4 by 6, and 8 times 3. 8 by 3.
And then how many more should we have left? Maggie, you want to give me the rest of them?
24 by 1.
24 by 1.
12 by 2.
That's 8. Is that all? Okay. So all of these, what do you notice about each of these? What is 6 times 4?
24.
24. And 3 times 8 is?
24.
24. And 2 times 12 is 24. And 1 times 24 is 24. And the same is true for all of these, right? Because basically what we did was we found all of the factor pairs for 24. But if we replaced L and W with X and Y, so this is X and this is Y, what did X times Y always equal for this pattern?
24.
24. This pattern here, where X times Y equals a constant, what letter do we use for constant here? K. When X times Y equals the constant, this is what inverse variation looks like. Now, if we were wanting to get it into Y equals form, if we wanted Y by itself, what would we divide by on both sides? X. So that would be Y equals K divided by X. These 2 equations here represent an inverse variation relationship. This graph looks a lot different than the graph of a direct variation graph. So if you have your calculator and you want to get that out, go ahead and get out your calculator, and I'll turn on mine. And we're going to graph that equation that we just did. What was K for us?
24.
K was 24. And so in order to graph, we need to be in Y equals form. So go to your Y equals and clear that out. And we're going to do Y equals, and if we look at this equation here, K was 24, so we're graphing Y equals 24 divided by X. So Y equals 24 divided by X. And we're going to hit zoom and 6 because remember last class we changed our window to be that really strange window, and today we want to go back to the standard window. So if you hit the zoom button that's at the top in the middle, if you notice number 6 says standard, that'll take us back to the graph that goes from -10 to +10 in both on the y-axis and the x-axis. So we just choose 6, and it looks like this. Let's make it a little bit bigger. Go to your window and make each of those 20. So we're going to say negative 20 to positive 20. I just want you to get a little bit bigger picture of the graph. And the y minimum to negative 20, and the y maximum to positive 20. Yeah, that's going to give us a better picture. If you just push graph when you're done, that'll take you back. I went to window, and in window, this is what my window looked like. I never mess with the X scale and the Y scale, those two there, or the X resolution. I don't ever mess with those. The only things I ever change are the minimum and the maximum. So I changed them to negative 20 and positive 20. Now if you look at my table, what happens when X is 0? There's an error. Why is that? If you look at the equation, what happens if X is 0? It's undefined, isn't it? And so that's why when you look at, you can also look at your table if you want by hitting the second button and the graph button. If you hit second and graph, it'll give you a table. And do you see that it gives you a zero, it's an error? So a couple things we want to look at this graph. You see that you've got two different graphs and it's curving. What I want you to look at now is what happens if we made it negative 24 divided by X. Where are our graphs? What quadrants are they in?
1 and 3.
1 and 3, because it goes 1, 2, 3, 4. So 1 and 3. Let's go back to y equals. And I need to teach you something here. If you just type a negative, it's going to type over that 2. So if you want to insert a negative, do you see above this delete key it says INS? That's for insert. So if you hit second and that key, we can insert a negative. Uh-oh, I hit it, must have hit it twice. So now it's negative 24. What happened? Yeah, it's really a reflection. If you look, the graph from quadrant 1 reflected down to quadrant 4, and the one from quadrant 3 reflected up to quadrant 2. So when that constant is a negative, we're in quadrants 2 and 4. I'd like you to go ahead and sketch both of those graphs in your... Okay, your two graphs look like this, but there's a couple of important things we really need to talk about. These graphs are not C's, okay? They're not going to come back up and in. So the way you draw them is very important. What happens, let's go back, let's look at the table, because that's going to help us a lot. And I want you to look at what happens as X gets bigger. So we're going to look at the table. And we know that when X is 0, it's an error, but when X is 1, it's negative 24. Sorry. Everybody go to y equals, and let's take that negative out. Let's go back to positive. You can just hit delete, and it'll take just out that one negative. And once you've done that, you hit second and table. And if you're getting bogged down in the calculator, you can set it aside and just look at mine. And we'll watch what happens as X gets bigger. When X is 6, Y is 4. What's happening to Y? Smaller and smaller. And smaller. And smaller. Because what we're doing is we're constantly doing 24 divided by whatever. This is, for this last one, this is 24 divided by 65 is 0.36. We're doing a positive divided by, are we doing a positive or negative as we move to the right? As X gets bigger, is it staying positive or is it going to turn negative? It's going to stay positive, right? The larger X gets, it's going to continue to be positive. If we do a positive divided by a positive, can we get a negative? What is a positive divided by a positive? A positive, always. And so this Y value is never going to become negative, which means if you look at this graph, we're going to get smaller and smaller and smaller and smaller, but are we ever going to come down here into the negatives? No, and so can it cross this line? At this point right here, what is the value of y on this line? What does y equal? 0. Can I do 24 divided by something and get 0? No, the only way to divide and get 0 is if I have 0 on top. Well, that constant can't be 0, or it's not an inverse variation equation. So it gets closer and closer to 0. You were noticing that the y got smaller and smaller and smaller, but it's not going to touch the line, and it's not going to cross the line. So it gets smaller and smaller. So when you sketch this, it should look like it's getting closer and closer to, that was bad. It should look like it's getting closer and closer to the x and y axis, but it's not going to touch. And it's never going to come, your graph should never look like this. It's not going to curve back in. It's not going to go that direction. It's going to get closer and closer to those zeros. In Algebra 2, you'll call those, well, you won't technically take Algebra 2, but in your other math classes, you'll call those asymptotes. Asymptotes are lines that your graph comes really close to, but doesn't ever actually cross or touch.
So it just forever goes on?
Right, forever. If we went, we could keep hitting this down arrow, and we could keep looking. I think there's a way to plug in values for x, like, oh, let me do that. No, I don't. I'll figure that out. You can choose your value for x, and it'll tell you. But that's the graph of an inverse variation equation. Okay. So the name of that graph was a hyperbola. You'll want to write that down. That was a hyperbola. Okay, let's look at another relationship. For most flying birds, I think this is really interesting because it's true. For most flying birds, the length of their wings times, get this right, the number of beats per second is equal to 1800. Their wing length times the number of beats per second equals 1800. So if you think about like an owl, is their wing length large or small? Owls, eagles, big birds. They have a big wingspan. I'm comparing them in my head already to another bird, and you don't know what bird that is. So they're pretty big. How many beats per second do they have to do when they're flying? Not very many, right? But when you think about a hummingbird, how is their wing length compared with like an owl? It's tiny, right? And how many beats per second do they do? A whole lot, right? You can't even see it. And so their wing length is shorter, so their beats per second has to be greater, because for the owl they have a big wing length and they have a small number here. But this looks like W, well, let's make that L for length. The length times the beats per second equals 1800. Does this look like inverse variation? Is it a variable times a variable equal to a constant?
Yeah.
Yeah, that looks like x times y equals k. What is k?
Constant?
Yes, and what is it for this equation? 1800. So this 1800 is our k. It's our constant of variation. So if I tell you that a hummingbird, it's a certain type of hummingbird, has a wing length of 48 millimeters. That's its L. That's its wing length is 48 millimeters. So keep in mind, 48 millimeters is how many centimeters?
4.8.
4.8. So it's not even 5 centimeters long.
With like both their wings?
I believe it's just one wing. It just says wing length. It doesn't say, what is this called from 6 to 6? Wingspan. It just says wing length, so that ought to be here. So if we know L, can we find the number of beats per second? Yeah, so let's do that. So 48 times B equals 1800. And how do I solve for B? Divide by 48. You can go ahead and do that on your calculator so you can tell me quickly. What'd you get? 37.5 what is this? Beats per second. Wow. I mean, you know it's fast, but 37 beats per second is a lot. Okay, so let's make a list of the things that you need to be able to do. You need to be able to identify an inverse variation equation. You need to be able to identify an inverse variation graph. You need to be able to, let's say, also identify an inverse variation from a table, just like we did with the direct variation. Look at the table of values or a set of ordered pairs and say, yes, it's inverse variation, or no, it's not. And you're always looking for x times y to be constant when you're looking at that table. So if you look at a table and it has the ordered pair 2, 4, and the ordered pair 6, 12. Does that look like inverse variation? What's 2 times 4? 8. What's 6 times 12? Is that inverse variation? No, because x times y is not constant. But what if this was 1/2 comma 16? Would that be inverse variation? Yes. All right, I'm going to give you a little bit of time to work on the homework out of the book, and then we're going to do some practice stuff on the board.